Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how fighter jets manage to carry massive missiles weighing over 200 kilograms, revealing the hidden engineering inside their wings and the incredible design that keeps the aircraft stable even during violent maneuvers. The solution is a reinforced anchor called a hardpoint. A hardpoint is a specially engineered structural location on an aircraft airframe designed to attach and support external loads, including missiles, bombs, fuel tanks, and sensor pods. Fighter jets typically feature 8 to 13 hardpoints distributed across wings, fuselage, and tail sections. Each hardpoint is structurally reinforced with internal bracing, additional material thickness, and reinforced internal pathways to safely transfer the weight and forces from external loads to the aircraft's primary structure. Hardpoints must withstand not only static weight, but also dynamic forces generated during acceleration, maneuvers, and weapons release. The F-16 Fighting Falcon features 9 primary hardpoints, 1 fuselage station, 4 wing stations per side. The Rafale fighter jet uses 13 hardpoints strategically positioned to support various weapons configurations. Typical hardpoint locations include wing tips, inner wing sections, mid-wing sections, and fuselage stations. This distributed arrangement allows weapons planners to optimize load configurations for specific missions whilst maintaining aircraft balance and aerodynamic efficiency. The F-15EX Eagle carries 23 hardpoints, providing exceptional flexibility for weapons carriage. Air-to-air missiles like the AIM-120, Advanced Medium-Range Air-to-Air Missile, weigh approximately 200 to 230 kilograms. The Meteor air-to-air missile, used by European NATO countries, weighs approximately 190 kilograms. Air-to-ground missiles are substantially heavier. The AGM-158, Joint Air-to-Surface Standoff Missile, weighs approximately 1,000 kilograms. Traditional bombs and guided munitions range from 250 kilograms to 900 kilograms or more for large precision-guided weapons. Fighter jets must accommodate this entire range of missile weights safely across different hardpoint configurations. When a fighter jet carries a 200-plus kilogram missile on a hardpoint, the hardpoint must safely transfer that weight and all associated forces to the aircraft's primary load-bearing structure, the fuselage, wing box, or control surfaces. Modern aircraft use reinforced attach fittings, internal doublers, and carefully calculated stress paths to distribute the load across larger structural areas. The structural integrity of each hardpoint is rigorously tested during aircraft certification. Structural engineers design hardpoint attach points to withstand loads at least 1.5 times greater than expected operational loads to ensure safety margins. This engineering ensures that missiles weighing over 200 kilograms can be carried safely during normal flight operations and combat maneuvers. The F-16 Fighting Falcon carries approximately 7,700 kilograms of total ordnance across 9 hardpoints. The Rafale fighter jet carries up to 9,500 kilograms of external ordnance. The F-35 Lightning II accommodates approximately 8,200 kilograms of external payload. The F-15EX Eagle provides the highest payload capacity at 13,300 kilograms across 23 hardpoints. These payload capacities represent maximum external loads. Actual configurations vary based on mission requirements, fuel requirements, and aircraft performance targets. Heavier weapons loads reduce aircraft range and maneuverability compared to lighter configurations, so mission planners carefully select optimal weapons configurations for each sortie. A typical combat mission might see an F-16 carrying 4 missiles approximately 200 kilograms each on outer wing and fuselage hardpoints, totaling approximately 800 kilograms of air-to-air missiles alone. The Rafale fighter can carry 6 air-to-air missiles on a single sortie. The F-35 carries 4 to 6 air-to-air missiles internally or externally, depending on configuration. Multiple missiles on a single aircraft are distributed across different hardpoints rather than concentrated on one location, allowing more even load distribution and optimal aerodynamic balance. This capability enables fighter jets to engage multiple targets simultaneously or maintain substantial reserve weapons after initial engagements. Mounting external missiles and weapons on fighter jet hardpoints increases aerodynamic drag significantly. Each external store disrupts smooth airflow around the aircraft, creating additional drag forces. This increased drag reduces maximum speed by approximately 5 to 15%, reduces combat range, and increases fuel consumption. To minimize these effects, fighter jets use conformal fuel tanks that follow the aircraft contour rather than external pods, and position weapons to create minimal aerodynamic disruption. Internally mounted weapons in weapons bays eliminate most aerodynamic penalties, which partially explains the stealth fighter's advantages in supersonic flight and range performance despite smaller external payload capacity. Each fighter jet hardpoint undergoes extensive structural testing before aircraft certification. Testing includes static load tests, where the hardpoint is subjected to forces far exceeding operational requirements, typically 1.5 to 2.0 times the maximum expected load. Dynamic testing simulates acceleration forces, vibration, and shock loads that occur during flight. Fatigue testing subjects hardpoints to millions of load cycles, simulating extended operational use. Any hardpoint failure during testing results in design modifications before aircraft enter service. This rigorous certification process ensures that missiles weighing 200+ kilograms can be carried safely throughout the aircraft's operational life. Fighter pilots receive comprehensive training in managing aircraft behavior with various weapons loads. Heavy external ordnance changes the aircraft's center of gravity, maneuverability characteristics, and fuel consumption. Pilots practice takeoffs and landings with maximum weapons loads, learning how runway requirements increase and aircraft handling changes. Simulator training allows pilots to experience how external missiles affect acceleration, turning performance, and recovery from unusual attitudes. Pilots learn to calculate appropriate configuration changes for different mission requirements, selecting lighter loads for air superiority missions and heavier loads for strike missions. This training ensures pilots safely manage aircraft behavior across the full range of combat-loaded configurations. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.